Hi, I'm Scott Allen Miller, and today on Sam IT I'm going to talk about why it's problematic to use a SAN as a way to share files between machines. Now, people talk about should I use a SAN or a NAS all the time, and there's some interesting reasons in the last decade as to why this has started to become a question. And mostly that's because in virtualization we have an opportunity to generally use one or the other for that same role, and so people over time have started to associate the two as having some relationship in how they work. But this is not the case. Prior to virtualization, you really never heard people have conversations about choosing between a SAN or a NAS because they are so completely different that they really never came up in the same circumstances. Whatever your workload is, whatever the task is you're trying to accomplish, it's generally pretty clear that you need a NAS or a SAN, never a decision point. Kind of like, do I need a car or a boat? You generally know right away which one you need. You don't hear people having discussions about, should I choose a car? Should I choose a boat? No. Is there water? Then your car's not going to work. That's it, right? It's that simple. SAN and NAS are very different things, and we've covered this in other places. SAN is block protocols over the network. That is, anything that's presented by a SAN will appear like a local disk to whatever is using it. NAS, on the other hand, is just an appliance-sized file server, so it's network storage, network file systems over the network. Both are storage, both go over the network, but they are fundamentally different things. One presents a file structure, the other presents block storage. So one to the device looks like you're attaching a hard drive, a SATA drive, a SAS drive, a fiber channel drive, something of that nature. The other looks like a mapped drive, right? These are fundamentally different things. At the end of the day, they both end up being storage that you can consume, but they are fundamentally different things under the hood. You would never confuse a file system with a hard drive, and in the same way you should never confuse a NAS with a SAN. That being said, when people want to go share files, often SANs are mentioned. And can you use a SAN in this role? Well, sort of. Let's back up. If you're using a NAS, this is just a file server. So a NAS is a full server. It stores your files. You map drives to it, or map whatever, mount points. And everyone who needs to access those files is able to do so over the network. You're contacting a server asking for a file. That server may ask for your credentials. It may look and see if the file is locked, things like that. It has arbitration. It is what we expect when we deal with shared files, because it's what we deal with every day. It's how we always deal with shared files. We're used to there being a server that arbitrates that. When we're dealing with a SAN, we don't have that same logic. We don't have that arbitration. What we have is, for all intents and purposes, a disk that has been exposed to the network. Now, it may be many disks under the hood, it may be very high-end and very reliable, it may be extremely fast, but it doesn't change the fact that it behaves like a disk. If you're in a situation where you can take a single disk and connect it using physical cabling to multiple servers to accomplish your task, that would be a case where a SAN could work. SANs are less cumbersome than actually wiring a single disk to many servers, but that's the only difference. The technology is exactly the same. Would you be comfortable with 3 or 4 servers all talking to a single hard drive that don't talk to each other, and a hard drive that doesn't care who's talking to it? Probably not. Why would you be comfortable with a SAN doing the same thing, especially given that you probably spent a lot more money on that SAN than you did on that hard drive? The problem here is there's no arbitration. With a NAS, you don't have to trust your endpoints because the NAS, or the file server, is going to query them. It's going to ask who wants to access the data. It might ask for a password. It might look at IP addresses. It might do a lot of things to determine who's allowed to access a file and in what way. SANs don't have this capability. They simply know that this endpoint is able to connect. You may have enough security to connect the endpoint, but nothing further. And once an endpoint has control of that block device, it's simply trusted. That means that each of those endpoints, remember, endpoints that know nothing about each other, are now writing to a disk. That means they can accidentally overwrite each other. They can try to make the disk do things it doesn't want to do, like access things non-sequentially, because they each have different requirements and they have no idea how to prioritize because they're not talking to each other. They can get data they shouldn't have access to because they don't know anything about security, because they have to be trusted. NASs don't have to trust their endpoints, but SANs do. That means that you, as someone using a SAN, have to trust that everyone it trusts can be trusted by you. Not just, do I trust them to try to do the right thing, you also have to trust them to do the right thing. To put this into a different perspective, imagine a blank piece of paper. And you have 5 different people who need to write and retrieve data from that piece of paper. But none of them are allowed to look at that paper. They're only allowed to write to it. So each one writes to a different spot. They're able to see enough to know how to write, but they never read what's already there. Chances are, over time, they will try to write to the same spots on the paper. Every so often, they will read back what's on the paper, but they won't do so knowing that they were the last ones that wrote to it. They'll think they were because they don't know about anyone else writing to it, but someone else may be writing onto that paper and maybe in the same spots that they already are. The paper kind of makes it hard to understand a little bit because you would always see what you're writing, and it's really easy to look at an entire piece of paper at once. Unlike a hard drive where we don't read the entire hard drive into memory and write the whole thing back and look for changes as it happens. So it's a little bit more complex than that, but you can kind of picture what's happening. It's a lot of different people putting letters and characters into the same space without checking with each other and having no way to tell when they're overwriting each other. That's what SAN will cause to happen by nature. So if you want to use this to share files between lots of machines, you have some complexity to overcome, and that's why we generally don't do this. Now there is a tool for making this possible, and it happens at another layer, and it's called a clustered file system. The way that a clustered file system works at the very high level is that it's a file system, obviously, that has some additional components to it, such as a space where all machines agree that they will write and keep track of their changes so that they can tell other nodes when they've been making changes. Of course, this has overhead, and it still requires that each of those nodes completely trust each other because anyone acting inappropriately will corrupt the data for everyone and can access things it shouldn't be able to access and so forth. But assuming you truly do trust all nodes from a security perspective, then this gives you an opportunity to potentially trust them from a technology perspective, that they will not intentionally do the wrong thing. And clustered file systems can work very well, and this is how things like your virtualization machines that need to share SAN storage between multiple hosts work. They have very simplistic clustered file systems combined with very large files that need very little interaction between hosts so that they need very little communications in order to do what they do. So virtualization tends to lend itself to clustered file systems in a way that other types of file serving does not. We don't generally use a SAN for this because it requires that if you're going to share it with, say, desktops or servers, you have to install clustered file system drivers and keep them working and trust every node completely. And that's a lot of work, all for just not using a SAN, all for just not using a NAS, just because we want to use a SAN. SANs are not particularly good at this task, so why would we want to push to do this? The only real cases where this comes up is there are very specific cases where we have a system where NAS does not perform very well or doesn't meet the needs. As is often the case with SAN, it's a brute force methodology to solve things that are technically difficult under other circumstances. Because SAN gives us full block access to the underlying device, it allows things like databases that want to talk directly to the block instead of to a file system to do so. So there's exceptions to the general rules of how we access things, but that's normally where SAN is going to come into play. The one industry that seems to use this more than others and where we see it come up the most is in video processing. And this is for the same reason, it's just a little bit different use case. With a lot of video and high-end photo processing, some applications demand block level access directly to the files so that they can manipulate them in some complex ways. This is a weird thing, and those applications should probably rethink how they work with files, but short of actually switching out the applications, often the only choice we have is to use SANs instead of NAS, and to then either not allow files to be shared between machines, which kind of defeats the purpose, or to resort to a clustered file system in order to overcome that. So in certain industries, it is relatively common to actually find third-party clustered file systems being applied even to desktops used for certain things like video editing in order to make SANs capable of sharing files in a relatively safe way. It's still a bit of a kludge, but it works pretty well, and the performance can be pretty good, especially because they mimic VMs in that they are very large files that tend not to be shared. It's just that you're making sure someone doesn't directly overwrite the space, because blocks need to go all over the disk and the machines need to know where those blocks are. But it's pretty easy for them to share, under those circumstances. So that's where we tend to see SANs being used for sharing. But if you don't have an absolute concrete technical need as to why it must be a SAN instead of a NAS that you're going to use, assume that SANs should not even come up in any conversation involving file sharing. That is a fallback, brute force, very complicated and dangerous method that you don't want to even consider if you can get away with it in some other way. And 99.99% of the time, a NAS or traditional file server is going to do what you need just perfectly. So don't feel that you ever need to really consider a SAN. It doesn't need to come up. Now, that being said, if you're working with virtualization, that's the one case where there's a good chance you're going to want to just go SAN. In those situations where you want external storage, which are extremely rare, and we can cover that at another time. Thanks for joining me. I'm Scott Allen Miller, and this is the Sam IT channel. Remember to like and subscribe, and you can sponsor us on Patreon, and you can join the conversation below or at the links we provide so that you can talk more about SAN, NAS, file servers, and storage, and how they affect you and questions you may have.